So nuclear physics. Scary, huh? That's pretty scary. But you know what's worse? So nuclear physics, what is it? You don't have an answer? Alright, let me Google it. So nuclear physics is the physics of the atomic nuclei and their interactions, especially in the generation of nuclear energy. What? You still don't get it? Alright, I guess I'll have to go into some more detail. So in order to understand nuclear physics, we have to understand atoms. In the nucleus of an atom, there are positively charged protons and negatively charged neutrons. Together, they make nucleons. Different elements have different atomic mass numbers and atomic numbers. Wait, what are those? Wait, you don't know what those are? Didn't you take chemistry? Well, for those of us people who forgot chemistry, or the younger people that are watching this video that are not entirely sure, atomic mass is the mass of an atom measured in AMU, or atomic mass units, which are really small. And the atomic number of an atom is used to identify different elements. For example, the sixth element in the periodic table, carbon, has an atomic number of 6. It also matches the number of protons it has in the atom, which is, again, 6. And another thing you need to know is isotopes. Isotopes are the same element, but a little bit different because they vary in the number of neutrons in the nucleus. For example, we have carbon-12 here. It has 6 protons and 6 neutrons. 6 plus 6 equals 12, hence the name carbon-12. And then we have carbon-13, which, as you can guess, also has 6 protons since it's the same atom, but it has 7 neutrons, and 6 plus 7 equals 13. Again, the name carbon-13. Since the number of protons doesn't change, but the mass number does, that makes carbon-13 an isotope of carbon-12, or carbon in general. With isotopes, they're the same element, but have different numbers of neutrons in the nucleus. I wonder what that does. Maybe that leads to decay and nuclear radiation. So for the unstable nuclei, or the unstable isotopes of, let's say, carbon, we have carbon-12, which is very stable, the most common, and then carbon-13, which is unstable and has radioactive decay. Radioactive decay is when an unstable nucleus, well, decays. Wait, you saying that there's more than one type of radioactive decay? You're right. You're smarter than you let on. So first we have alpha decay, which is where the nucleus of an atom loses 2 protons and 2 neutrons, or 2 nucleons if you remember that from earlier. And this is a transmutation, where the element is no longer the same after alpha decay. So when carbon-14 undergoes alpha decay, it actually turns into beryllium, which is kind of amazing when you think about it. You could take one element that's unstable and turn it into another element just from a natural process of radioactive decay. But yes, I did mention there are other kinds of decay, which is beta decay. During beta minus decay, a neutron turns into a proton and releases an electron and an antineutrino. Neutrinos are just tiny neutral particles. This causes the atom to gain a proton and increase its atomic number by 1. And beta plus decay is basically the opposite, where a proton this time turns into a neutron, and in doing so, emits a neutrino and a positron. Positrons are just the antimatter counterpart to the electron. And after beta plus decay, the atomic number decreases by 1. Pretty simple, huh? Now we get on to gamma decay, which is the last type. This one's a little different from the others because there is no fancy emitting of protons and neutrons, or protons and neutrons changing and flipping into each other. This one, just energy is emitted. Gamma decay happens when an atom is too excited to be stable. And like a chihuahua pees on the floor when it gets excited to see its owner come home after a day of work, an excited atom will emit gamma rays in order to lower its energy to become stable again. And those gamma rays are pretty dangerous. Gamma rays can penetrate several centimeters of lead or several meters of concrete. That's a lot of concrete. And as you can imagine, are very damaging to the cells deep inside of you and me. Alright, so now that all the stuff you should have learned in chemistry is out of the way, let's get into the more exciting stuff. I'm sure you've never heard of E equals MC squared before, but do you know what it really means? E equals MC squared boils down to mass, over here, being equal to energy. E equals mc squared essentially means that mass and energy are the same thing. Pfft, mind blown. I didn't really think about that the first time I saw the equation, not gonna lie. But not only are they the same thing, but they can be converted from one to another. Just like that. And of course, breaking down the equation itself, we have E, obviously equaling energy, is equal to mass times the speed of light squared. This means that a very small amount of mass equals a ton of freaking energy. How much energy could you make from something like, let's say, 1 kilogram of mass, which is a heck of a lot less than this 20 pounds. Actually, about 1/10 of that 20 pounds. So using E equals mc squared, plugging in 1 kilogram for the mass, and obviously solving for energy, you would get 9 times 10 to the 16th joules of energy. That's a 9 with 16 freaking zeros behind it. And using the equation you learned in the slideshow that we just saw, that could power a 100-watt light bulb for 28,519,279 years. That's a lot of years. In fact, if that light bulb shut off today, ran out of energy, it would have been turned on when the Swiss Alps were forming. That's what was happening 28,519,279 years ago. So in recap here, atoms have a nucleus made out of protons, neutrons, and are orbited by electrons. And protons and neutrons together are called nucleons. Atoms with too much or not enough neutrons in their nucleus can become unstable and decay. There are 3 types of decay: alpha, beta, and gamma. In alpha decay, an alpha particle is emitted, which is just 2 nucleons or a helium atom. In beta decay, there's 2 types. Beta minus emits a nucleon and a neutron changes into a proton. In beta plus, a proton changes into a neutron and releases a positron. And gamma decay just releases high energy gamma rays. And 1 kilogram of mass can power a light bulb for 28,519,279 years using E equals mc squared. Alright, that's it for today, guys. Thanks for watching, and please subscribe because it would mean a lot. And see you guys next time. Oh, crap, don't fall.
Come in.
Did you get the presentation?
What a bunch of absolute idiotic nonsense. What a waste of learning. What's Dawson teaching you?
What do you mean?
I thought that by teaching you chemistry, the central science, the entire school would thrive. But you've shown me it's impossible. As long as there are subjects to challenge the possibility of what chemistry could be, there will be those who are unable to accept what it should be. They'll reject it.
What do you mean? It shouldn't matter what we're learning or how we're learning it. It should just matter that we're still continuing to learn stuff.
That sounds like something a middle school teacher would say. I'm thankful because now I know what I have to do. I will erase half of all of physics, leaving students thriving to obtain scientific knowledge and to seek out the superiority of chemistry. It shall be a grateful school system.
But why would you do that? If you do that, nothing will make sense. Nothing will connect. There won't be any connection between the two sciences.
It matters not. The work shall be completed. It always will be. Chemistry is inevitable.
No, don't do it.